Spark has a very nice and concise documentation, especially about the Spark data frames and the main API. In this session, I hope to save you some time from reading this documentation, at least some time, and we'll go through this documentation together. So in Spark, the main entry point into the functionality of Spark is just the Spark session class, the Spark session class. So the first thing you want to do is to create such a basic Spark session class. In order to create it, you use a builder. So they used the builder pattern where you specify properties one after another. So first we import the Spark session. We do from PySpark.sql import Spark session. We are referencing here only the Python language. So we imported the Spark session and then we do Spark equals, this is the name of the variable that we give it, the Spark session is Spark session.builder. And then we start giving it some properties like Spark session.builder.appname, and you give it in brackets your app name, for example, Python Spark SQL basic example. .config, then you give it some key value configurations, and then .get or create, which will actually return to you the Spark session. So let's repeat it. Spark session.builder.appname, your app name, .config, some configurations, .get or create. And that's it. With it, you have a Spark session object in hand where you could start getting into the actual API, creating data frames and moving on. And now that we have the Spark session at hand, we start creating data frames. For example, if you want to create a data frame from a JSON, then you use Spark session. This is the variable that you have from creating the Spark session. So in the documentation, they call it just Spark because this is the reference for you to access Spark. So you do spark.read.json in this example, and then you provide to it the JSON file path. You assign this to a variable. The standard is df, so df equals spark.read.json and the JSON file name. And then you can do just df.show with round brackets. And it will show you the properties that you have in this data frame. So this was very basic, two commands. Spark session .builder.appname.config.get or create, and then you use this Spark object that you got to start creating data frames, spark.read.json or spark.read.csv, and then the third command, df.show and round brackets. And this is it. You created a Spark session, you created a data frame from a JSON file, and you have shown it. You have printed this data frame. Now that you have a data frame, let's start accessing this data frame. So if you want to access a property or a field from the data frame, you just do df.h. This will give you back the h property of the data frame, like all the rows, and from all the rows it would select the h property. Another option, which is even more recommended by Spark because they say that in future it wants less prone to be broken, is df square brackets and then in a single quotes h. So df square brackets and h, this would return you with the h column. In order to print the data frame, you just do df.print schema. And this would print the columns that you have. For example, in the data frame that they gave in the example in the documentation, they had two columns. One is age of type long, nullable true, so it could accept null values, and another property is name of type string. Another way to get only one column is that you can do df.select, then name, then if you do .show, it would show you this column. So if you would do df.select and then in round brackets name.show, it would show the column name and then all the values, Michael and the Justin. And of course, if we didn't use the .show, we could assign it into another data frame. If you want to select multiple columns, then you could do df.select, and then in the round brackets, you do df square brackets name, comma df square brackets age. So this could be a little bit perplexing because you're doing df.select and then you're giving it as parameters another time the df. You could expect that you would do df.select and only the property name. But in this example, what they wanted to show you is that they select the actual property columns, and when they select it, they increment the age by 1. So what I did is df.select and then in brackets df square brackets name, comma df square brackets age plus 1. Okay, and with this you get another data frame where you increase the age by 1, the column age by 1. So this can be very useful when you have a data frame and you want to manipulate one of the columns. So you are like applying the function to one of the columns and then you get back a new data frame. So another very common operation is that you say, I want to get this df, this data frame, but I want only the rows where the age is larger than 21. Give me all the people with the age more than 21. So what you do is df.filter, and again in brackets, the little bit mixing part is that you again insert df square brackets age greater than 21. So let's repeat. If we want to get all the people that are older than 21, we do df.filter, and then in the brackets, we can't just give the column name because it's not the column name that is greater than 21, it's the actual data frame and the actual column. So we give it the actual data frame and the actual column. So we do df.filter, df square brackets age greater than 21. And now let's say that we want to do like an SQL group by. So in SQL, what we could do is we could say group by the age. So I want to know how many people are having an age of 19, how many people are having an age of 30, and since we allow the age column to be of a null value, then we want to also to know how many people have an age of null, or in other words, for how many people does this data frame does not have a value of a number in the age. So the way we do this, you could have guessed it, df.group by. And then we give only the column name because we are not doing any manipulation with the column. Age and then dot count because we want to count. We want to do a group by and count. So the basic rule of thumb is whenever you want just the column, you can insert it to the function, just the column name. But when you want to do an operation or a condition on the column, you can't just give the column, at least not from this documentation. You give df, the data frame, and then in square brackets, the name of the column. Okay, so these were the basic operations. We did df.select, df.filter, df.group by. Whenever we needed only the column name, like in group by, we didn't have a condition, then we just gave the column name. And when we wanted to apply a condition or to apply an actual operation, like increase the age by 1, then into the df.select or df.filter, we don't give the column name, we give actually df and square brackets and then the column name and then either greater than 21 or plus 1, depending if you want to do an operation or just get the column value. And we continue to go to the Spark API documentation, specifically for Python, and now we have reached the part where they actually discuss how you could run SQL commands on a Spark data frame. So it's very intuitive because you just run spark.sql and then your SQL command. Very, very intuitive. However, you ask yourself, what is the table that I'm executing this SQL on? Do I take the data frame variable name? So no, what you do is that you need to tell Spark, create a temporary view or a table for me and give it a name, and then I will execute the SQL on this name. So the way it's going is like this. You do df, this is your data frame df.create or replace temp view, and you give it as an argument the table name. For example, they give it people. And then they created another variable called SQLDF and assigned to it spark.sql. Now we need to give it as an argument the SQL string, which is just a string select star from people. So df.create or replace temp view, give it the name of the table that you want to execute SQL on, and then spark.sql, the string of your SQL. That's it. The previous function that we used, df.create or replace temp view, has created a name for you. We gave it as an argument the name people, and it created a table where we could actually execute SQL commands with spark.sql. However, once the session terminates, then the documentation says that this view would also terminate. Therefore, what we want to do is to create some kind of a global view which would live across sessions and would terminate only when the Spark application terminates. So instead of using the previous method of df.create or replace temp view, we use df.create global temp view, and we give it as the same as we gave previously, the name people, which is the table name. However, here we have some kind of a gotcha, because you can't just run the SQL with spark.sql and then the standard.sql. You need to prefix the table name with global temp. So now when you execute the SQL query, you execute it with spark.sql, select star from global temp dot people. Okay? And it's cross session. So if you create a new session with spark.new session, then you could immediately execute an SQL select star from global temp dot people. And now the documentation moves to datasets. So it first speaks about how to create a dataset, and it says that datasets are similar to RDDs. However, instead of using the Java serialization or CRYO, they use specialized encoders. So datasets, as the documentation says, is similar to RDD. However, they use special encoder, and these special encoders to serialize the data and the objects when you transmit them over the network will allow you to do operations such as filtering, sorting, and hashing without deserializing the bytes back into an object. So with RDD, you first need to deserialize, and with datasets, you don't need to deserialize because it's using a different encoder. And below is using Scala or Java code. So the way they define a new dataset now is that they don't, in this example, create it from a file, but create it from just an object. So they first created a case class named person with two fields, name and age. And then they created a sequence, which is like a list. Okay, in Scala, it's the interface. And then they added the person, and then they, on this sequence, this is like on the data type, they executed the function 2ds, and this has converted it into a data set. So you can basically take in Scala any sequence or list of objects and then apply the function 2ds. And then you could use the standard, if you're familiar with Scala or with streams, you can use the standard streaming method such as map. So you could use the ds.map and then apply to it a function to do +1 and then .collect, which would actually get back an array. You could also create a dataset by providing it with a class. So if our class is person, we could do spark session.read.json, give it the path of the JSON that we want to read, and then s.s, and then the type, which is a person. And we would get an array of persons, simply. So now the documentation asks us and itself, now that we have RDDs, data frame, data sets, what if we want to use data frame and we have RDD at hand, or the other way around? So they give an example and they say that they can do it in general in two ways. One is with reflection and another one with programmatically specifying the schema. The first way of inferring by reflection, they give an example where with 3 lines, they read a text file and convert each line into row. The way they do it is that the first line reads the text file with se.text file. The second line uses lines.map lambda split comma, which is splitting each line into multiple columns. And they map the multiple columns into a row object. So then they do parts.map lambda. For each item, create an object of row. They do this with row and brackets, and then they take the first item into name and the second item into age. So with 3 lines, they read the text file, converted each line into a row object. And now we want to infer the schema and register a data frame as a table. The way we do this is schema people is assigned with spark.create data frame, and the object that we got from the previous line is the list of people where each line is a row, and then schema people.create or replace time view, the usual, and the name of the table, and then we can simply refer to it as a standard data frame. Now, if you want to take this data frame and convert it into an RDD, it's very simple. You just do .rdd. Okay, you take the data frame and then call the function .rdd and you have an RDD at hand. That's it. So in the previous example, we used reflection in order to convert in between RDD and data frame, and now we are going to programmatically specify the schema. The way we are going to do this is first create an RDD, then create a schema, and then apply the schema into the RDD in order to create the data frame. How do you apply the schema into the RDD? You use the create data frame operation of Spark session. You remember this Spark session from the beginning that we created. So we call the Spark session .create data frame and we give it 2 arguments. The first argument is the schema, and the schema you can look at it. It's a struct field, a string type. You just specify the schema of these 2 fields, and then you use the original object of Spark session, spark.create data frame. You give it 2 arguments. The first argument is the RDD, and the second argument is the schema, and that's it. You have a data frame. Next, we're almost at the end of this getting started from the documentation. And the next item is untyped, user-defined aggregate functions. Basically, what we want to do is we want to apply aggregate functions. We want to write these functions and then to apply them to the data frame that we have. And we want to get the result as an aggregation. So the way we register a function is that we call again this Spark session. We call Spark session.udf, user-defined function.register, and we give it in Scala, we give it an object. And this object extends, it inherits from user-defined aggregate function. And in the user-defined aggregate function, you need to implement a few functions such as input schema, buffer schema, data type, deterministic, is Boolean. And you actually define your functions. Your functions would be update and merge, and you define what to do with them, and then you have the evaluate function, which is calculates the final result. Once you have defined this function, then again you read a data frame. You can create or replace a temp view. And then when you do spark.sql and you run your standard SQL functions, standard SQL statements, you can actually use this UDF that we have registered in SQL. So imagine this, you write Scala code and then you take in SQL and you you have the ability to use a Scala function as an aggregation inside SQL. So they did select myAverage, and myAverage is the function that they defined in Scala on top of a salary column as average salary from employees. Amazing. And now for the last part, which is type-safe user-defined aggregate functions. So now they don't, if you remember, we have created an object which was called myAverage, and we extended the class, we extended user-defined aggregate function, but we didn't really give here any type. We used inside struct type, data type, double. Okay, but we didn't actually give this class, the myAverage, a specific type. So now they do object myAverage extends aggregator, and now they give in square brackets the types to this aggregator, which are the types are employee, average, and double. Okay? And now the difference in the usage is that when they read the JSON of employees, so they do sparks session.read.json and the JSON of employees, they don't just read it just like this, they also call .s and give in square brackets employee. So you don't only have a data set, a general one, or general data frame, you have now a data set with a type employee. Because when we read the JSON, we gave it a type. And now remember that we defined an object, myAverage extends aggregator, which is an aggregator function, and we defined it with the type employee. So this means we can now run this myAverage. So they call myAverage because it's an object. They call myAverage to column dot name average salary, and they get the value back. So they just called the object. They called a function in Scala, and they gave it as an input the column to work on, and they did do dataset.select average salary, and they show the average salary with result.show. To sum up with this, I think we have covered all the basics functionality and even more advanced of defining user-defined functions and types and without types and reflection and how to convert between RDD and data frame. And we have seen all this, as strange as it may sound in a podcast. We have scanned the documentation of the Spark data frame and dataset and RDD. And we've seen that the basic object is a Spark session, that we can create a temporary or a global table, cross sessions, we can run SQLs, we can convert in between RDD and data frame and the dataset, we can run multiple operations, we can do aggregations, and at the end we define functions, one function without a schema and one function with a schema, and we call the aggregated operation on the dataset or data frame. So I hope you enjoyed it. I hope this would save you even a little bit of time. If you want to look at the actual documentation, just Google for Spark API SQL getting started, or Spark SQL guide, or Spark getting started API guide, or Spark data frame API. You got it. So I hope you enjoyed it. See you next time.